Alright, this is section 9.2, the very last extra example, which is from page 417 of the textbook, which is number 48 in the exercises about television. A researcher wanted to determine the mean number of hours per week, Sunday through Saturday, the typical person watches television. Results from the survey indicate that S sample standard deviation is 7.5 hours. Part A. How many people are needed to estimate the number of hours people watch television per week within 2 hours with 95% confidence? So 2 is your margin of error. 1.96 is the critical value that corresponds to 95% confidence. The sample standard deviation was 7.5 over the square root of the sample size. So again, it just takes some algebra to do this. The first thing I do is divide by the critical value, divide by 1.96. And so we have 2 divided by 1.96. And that gives us that decimal, 1.020408. And you don't have to write the whole thing down, but you do have to keep the whole thing stored in the calculator. And that equals 7.5 over the square root of the sample size. Some people like to put that over 1 and cross multiply. Really what you're doing is dividing the standard deviation by the answer. And so I do 7.5 divided by second negative. What that does is put the exact answer in there, so I'm not rounding at all. If you do it exactly, you get 7.35, and that is equal to the square root of n. 7.35. And then step 3 is to square that answer, to undo the square root. And if I square that, I get 54.0225, and we always round up, so we need 55 people in our sample. So part B, how many people are needed to estimate the number of hours people watch television per week within 1 hour with 95% confidence? Everything is the same except my margin of error just got cut in half. Instead of within 2, I want to be within 1. So instead of a 2 here, I'm going to put a 1 equals 1.96 times 7.5 over radical n. I do the same steps, divide, and square. When you do all of those steps, you should get 217 people. Don't forget to round up. In part C, what effect is doubling the required accuracy? So we're getting more accurate. That's why they say double. We're cutting our margin of error in half. That gets you twice as accurate. Doubling the required accuracy. Have on the sample size. So at first we only needed 55 people. Now we need 217 people. That is almost 4 times as many people. So doubling the accuracy requires quadrupling 4 times the sample size. And that's because of the square root feature. So to double it, you need 4 times as many. If you want to triple it, you need 9 times as many because of the square root in the formula. So if I want to be twice as accurate, I need 4 times as many people. Alright, that was part C. Part D. How many people are needed to estimate the number of hours people watch television per week within 2 hours? There's my margin of error. But now with only 90% confidence. And then we want to compare that to part A. And how does decreasing the level of confidence in the estimate affect the sample size? Alright. So, still 2. Critical value is going to change. Critical value for 90% confidence is 1.645. So that's 1.645 times the standard deviation over the square root of n. So again, we're going to follow these 3 steps. Divide s by the answer, and square. So if you do all those things, you should get 39 people. So the margin of error is the same as it was for part A, 2 hours and 2 hours. The difference is the critical value because of the level of confidence. So at first I wanted 95% confidence. I wanted more confidence. And in part D, I only need 90% confidence. That's less confidence. Everything else is the same. So this means that less confidence means you can take a smaller sample. More confidence requires a bigger sample. More confidence requires a bigger sample, which hopefully makes sense.